Good afternoon, good morning, or good evening from wherever you may be joining us today. Before we get going, I'd like to tell you about the TechWorks Awards and Gala Dinner. TechWorks is the parent organisation of AESIN, and every December it holds a big, very glamorous black tie event. This year, it's taking place in London at the Royal Lancaster Hotel near Hyde Park. It's on Wednesday, the 4th of December. And aside from the entertainment and the slap-up dinner, there will, of course, be awards. And the categories relevant to the AESIN audience will be Entrepreneur of the Year, TechWorks Contribution to Industry Award. There'll also be the Design Innovation Award, the Technology Breakthrough Award, Company of the Year Award, Startup of the Year, and the big one for the AESIN audience is the Automotive Systems Innovation Award. If you'd like to apply for a nomination for any of those awards categories, it's free, and you can do so by going to techworksawards.com. And if you're watching this broadcast live, in a couple of moments, I'll put the link in the Zoom chat facility. The deadline for applications to be nominated is 25th of October, so just over a month away, but don't delay, get your application in now if you would like to be nominated. As mentioned, it's completely free to apply, and you don't have to be an AESIN member to apply either, or you don't have to be affiliated with TechWorks in any way. So as I say, I'll put the link with all of the details in the Zoom chat facility in a couple of moments. Today's AESIN Tech Talk is entitled SOTIF, So What? Practical application of ISO 21448, safety of the intended function for autonomous vehicles. McMurran is a practice head with 3SK, which is a UK and India-based consultancy which supports SMEs and OEMs with the development of complex software and safety critical systems. Ross joins us today from Leicestershire. Ross, the floor is yours.
Thank you, Chris. I'll share my screen. Okay, hopefully that's visible.
That's visible, Ross. You're good to go.
Good. So, yes, I've had a long career in the automotive industry, it's fair to say, mainly working for OEMs, and including some early work in the field of autonomous vehicles as far back as the early 1990s. So it's been a field that's been in development for a long time. Today, I'd like to talk to you about SOTIF. And although we, 3SK and the industry have had extensive experience with functional safety, SOTIF is a new kid on the block. It's a new standard that's been out since mid-2022. So we thought it'd be useful to share with the network a bit about SOTIF and a bit about our first experiences with the application of it. So in the next 30 minutes or so, I'll take you through some of the key points about SOTIF, what it's trying to achieve, how it tries to achieve that, and some of the underlying concepts behind it, as well as sharing some of our learning points in implementing it. So, safety of intended functionality. It's applicable to a class of systems which use some form of sensing, perception, potentially even machine learning to build some form of situational awareness, and then take that information and automate a part or fully automate the driving task. SOTIF comes from the side of the ISO organization that looks at road vehicles. So you might be asking, well, haven't we already got safety standards? Well, yes, we do, but they're more about the functional safety, whereas SOTIF deals with something called insufficiencies, functional insufficiencies, or user interaction. So nothing's actually broken in this context. The system is actually working, but not working to a level where it still has safe behavior. It's probably easier for me to give you an example of what that actually means. So this is an example I've picked of autonomous parking. So it's often known as valet parking, but essentially it's a system where the user can be outside the car and the car can basically go and park itself. There's a few of these systems that are evolving and emerging. So what do I mean by a functional insufficiency? Well, it could be an insufficiency of the specification. So it could be an example where the field of view of the sensors isn't specified to give sufficient field of view, and there's part that's missed, and it might result in an unsafe behavior in terms of colliding with an object, potentially a human. A performance insufficiency could be where there's a sensor, it's specified, it's got a sufficient field of view, but there's particular conditions under which it might not detect objects, be an insufficiency. So an example might be very heavy rainfall. The standard also considers user interactions and specifically where a user might not do something which is expected, or might misuse the system in some manner. In this example, the system might be relying on the user holding down a dead man's handle on a phone or something like that, where they'd be expected to use it in line of sight and they don't. So again, these conditions have to be considered in the SOTIF standard. So high-level goals of SOTIF. So essentially, this eyeball diagram illustrates where your starting point and your end point should be. So you should basically be trying to maximize the number of known safe scenarios, minimize the potentially the risk from potentially hazardous scenarios, which can't be fully eliminated. And this is the bit that's challenging, is to try and minimize the risk from unknown scenarios. Obviously, the key word there is unknown. So sort of you have to try and manage that risk and recognize it. This is the process that's in the standard. It's a cleaned up version that we've done. Essentially, the main line of activity during the design and development is in this row here in the middle. So it's about understanding the system specification, identifying and evaluating hazards, defining the acceptance criteria, and then evaluating these insufficiencies and the conditions that might cause them, and then working out, do we need to improve our design? So iteratively improving the design. In parallel, working out, well, how we're going to verify and validate this. Again, for such systems, non-trivial task. So there needs to be a strategy of how you're going to do that. What you're going to do is component test, as simulation testing, as in-field testing. Typically, there'll be a blend between all those. Having improved the design to the level you think is good enough, and having got a strategy for the verification and validation, you need to go and execute that to evaluate known scenarios and the risk of unknown scenarios. And then you need to have a view of, have we done enough? Have we achieved it? And we'll talk a bit about the safety argument that you might have to do at this stage. If not, then clearly you need to iterate again. If so, and you've decided the system's safe to launch, then that doesn't end there. You've got to conduct in-field monitoring activities and be able to react to any in-field event as part of the SOTIF standard. So a key concept in SOTIF is this concept of having an operational design domain. And that's basically the conditions under which your system is designed to operate. And this needs careful thought. There's a lot of stuff out there. Fortunately, there's some stuff to help structure that and understand what that might look like. There's been some good work done here in the UK, which has now formed the basis for an ISO standard for an operational design domain specification. And typically, your operational design domain will consist of scenery elements, sort of fixed, non-movable things like roads, bridges, traffic lights. It will consist of environmental conditions, so that might be weather-related, it might be other atmospheric conditions such as dust, and then dynamic elements, so the movable objects, people, other vehicles, things like that. So those will all go into your operational design domain. And this needs careful consideration at your design stage to sort of say what is in there, what isn't in there, what can influence, what it can't do, what will be the influence of that design domain on my design, particularly these perception technologies. And you might have to make some really careful decisions here because that will significantly affect the cost and effort of the system under development. So how do you go about analysing for these insufficiencies and the conditions so that may cause those? So the standard has a diagram that looks something like this, and it shows this pathology of triggering conditions. So, for example, a severe weather event like fog, it might have an effect on a sensing system, which might cause the system not to detect a target, which might then cause some level of hazardous behaviour. So the analysis actually works back the way. So work out, okay, what, given the system we're trying to implement, what are the hazards? And again, we can use our old friends that we know from functional safety, like hazard and risk analysis, to sort of say, okay, what are the hazards? We can use things like fault trees to say, okay, what are the sort of relevant elements of my system that might cause those hazards? And then we can use techniques such as, I'll show this in a second, P diagrams, FMEA, to try and work out, all right, what are the conditions that could cause these factors. So this is just an example of how we've gone about looking at triggering factor analysis. Again, you might recognize this as a P diagram. So we've got a goal from a hazards analysis, what we want to achieve, i.e. not have this hazard or not have it unacceptable risk due to it. We've worked out from a fault tree analysis what kind of parts of the system could cause this type of hazard. And then we've used the ODD to capture some of the elements that might be involved. So the scenery parts, the environmental parts, the dynamic elements. And by going through this analysis, looking at each of these influencing or triggering factors, we've come up with strategies to say, do we think that's a risk? If so, what do we do about it? How do we deal with that type of influence? Do we upgrade the system? Do we restrict the ODD? Do we put in procedures? Do we need to do more testing? And again, there's a lot of very detailed analysis that has to be done at this side, at this time, looking at all these individual triggering factors. So moving on to having gone through this, optimize the design, right, now we need to test and verify it. first question is, okay, what is our acceptance standards? Now, SOTIF is about safety, so the acceptance standards should be formulated around that. In general, the guidance would be that an automated system should not be more unsafe than a non-automated system. So that's a starting point in terms of acceptance standards. But even then, you need to be careful that you've not got a transference of risk or harm from one group to another group, particularly if it's a more vulnerable group, shall we say. So you have to consider the acceptance standards, and then you need to work out, right, what's the evidence I'm going to gather? How do I get to that to know that I've done my job? So the result should be, again, going back to this eyeball diagram, should be able to calculate what the risks are, so the risks from these known scenarios, should be able to evaluate that. And also what we've found is, obviously, these are unknown scenarios. So clearly in your analysis, you've got to dig as much as you can to find those. From the results of the testing you've done, the known scenarios, you should look to see if is there any other previously unknown scenarios that you can add into that group. But eventually it comes down to how many new scenarios am I finding that were previously unknown, and what's the probability of causing harm. And that will give the confidence that you get to stage that, yeah, we've drained the pond, we've found the things. It will need a level of real world exposure because you won't find them all in simulation. So maybe just to make that a bit more obvious, this is kind of what we've kind of got is what we're trying to achieve. So initially, you've done your design analysis. You'll have set some targets for your rate of hazardous behavior. You'll have estimated the probabilities of that leading to harm, and you might, and having set the targets, to give yourself this margin for the stuff that you might not have found. And ideally, what will happen for your verification and validation, you'll actually prove that you've met your targets for the occurrence. You might have proven that that even when they do occur, it doesn't necessarily lead to harm, particularly if you've got safety systems around it. But then you need to continue this, oversight when you're actually operating in the real world to make sure that you've not gone in the wrong direction. People normally go, "Oh no, you've got a formula up," but it's one that I think many you'll be familiar with from functional safety, looking at the actual rate of occurrence of harm. So when a hazardous behavior occurs, it doesn't automatically mean that harm's going to occur. There's a number of conditional probabilities that you need to consider. One is exposure. So it might be that there's the at-risk group might not be present, or only present in very particular circumstances. Again, that could be influenced. So you've got to consider the exposure. How often will this, if the hazardous behavior occurs, will it be in a condition that can lead to the harm to the person group? There's controllability, which can be down to humans, but given you've automated the task, might not be fully controllable. But it can be controlled by a safety system. But obviously you have to then be sure that safety system is independent and not susceptible to the same insufficiencies that your primary system is. So there's some controllability to consider, and then there's will, even if all these things do still lead to the event, what level of harm will occur. Our approach in terms of developing V&V strategies has been to actually then start to break down these and focus testing and analysis on these individual factors. So testing the primary system for the occurrence of the event under the hazardous scenarios, looking at probabilities of exposed persons, going down, looking at particularly the safety system, testing that and its capability to prevent, even if the hazardous behaviour is exhibited at a primary level, will it lead to harm? Will the safety system catch it? And breaking those down to a lot of very much more smaller focus tests, rather than the potential massive explosion of state space if you try to test everything at once. So, having done your design optimization, your evaluation, your verification, you then need to decide, is this product sufficiently safe to go in the market? What can help that is a safety case. The SOTIF standard actually has two in the annexes. To be honest, there's really stylistic differences between the two. I suspect two groups independently developed them. So naturally, we then went and developed our own one, a 𝗧𝗹𝗸 style. But essentially, it's there to bring out the implicit argument that's in the SOTIF standard that says, if you do these things, your system will be sufficiently safe. So you've got to it shows that you've done the work and you've got the evidence that you've complied to the standard. So let me just give a bit more a zoomed in version, so it's not quite such an eyesight test. Again, assurance cases are used in functional safety. They're used in other areas where you need to get assurance of a particular property. They're very powerful because they can come at things from different angles in terms of giving an assurance from the technical perspective, from a process perspective, from an organizational perspective. So they can hook together a number of things that are covered in the standard. As you can see, the safety case we've developed using goal structuring notation. It's quite popular for constructing these safety cases. For those of you not familiar with it, basically you start off with a top goal. There might be some contextual elements, and then you deconstruct it using strategies into sub goals. And eventually you get down to bottom level goals with some solutions to them, which is generally the evidence that the bottom goal might be that you've verified a particular aspect of the system, and the solution will be the evidence from the test. So you can bring these things together. As with any safety case, it is really important that you do the safety case at the time you're doing the design rather than retrospectively, because you can then use the safety case to drive actions. You can use it to review your design. Is it any good? So in GSN 3, you've got the ability to put things like counter arguments, counter evidence to say, well, actually, I'm not sure about that, or I've got something that disputes that part of your safety case. Other things which are useful in safety cases, again, part of GSN 2 is you can have these assurance claim points where you can branch off. So you've said we're developing the system in the context of an organization. You can branch off to an argument that says actually the organization is capable because we've got people who are trained or expertise or whatever. And so you can incorporate, as I say, different sides of an argument. We actually use argument type indicators. We found it useful because you can argue for different aspects, both technical, process, organizational, these types of things. So we indicate this is what kind of argument we're presenting at the time. It just helps guide it through. So this should help make that release decision, that you've done all the things, you can put the product into the market. So just to conclude, SOTIF is applicable to road vehicle systems, particularly where they rely on this situational awareness built up for sensing and perception systems, and then go on and automate part of the driving task. It might be to do emergency intervention, it might be to fully automate the driving task or a specific aspect. It's applicable to the full range. It allows the structured approach to assessing safety. Again, it's complementary to functional safety. It's looking at these things, these insufficiencies, these user interactions, rather than the functional safety case of the behavior during malfunctions or failures. It ain't easy. There's because such systems are inherently complex, because the operational design domains will tend to be quite complex in themselves. There's a lot of analysis to be done to go through to understand the relevant factors, not getting away from that. And then there's a lot of testing to be done to get sufficient confidence that the product is good across all these factors and all these the full operational design domain. But again, the approach that we would stress is, if you break it down, take a reduction approach, it is possible to actually go through and prove that the product's safe using the standard. Okay, so hopefully that's given you an overview of SOTIF, what it's about, and hopefully I've left some time for some questions.
Thank you very much indeed, Ross. We'll get to the Q&A section in just a couple of moments' time. Already one or two questions coming through for you. At the top of today's broadcast, I was talking about the TechWorks Awards and Gala Dinner, which takes place in December, and namely the award, the Automotive Systems Innovation Award. If you'd like more details on that, and if you would like to apply to be nominated for the Automotive Systems Innovation Award, the link, if you're watching live, is in the Zoom chat facility. Excuse me, and it's completely free, and you don't have to be affiliated with AESIN or TechWorks to be able to apply. Yeah, any questions for Ross? Just put them in the Zoom chat right now, and we'll get to them in a couple of moments. Next month's AESIN Tech Talk takes place on Wednesday, the 16th of October. The presentation will be 𝗧𝗹𝗸 and the economics of hardware cyber security, and that's with Peter Davies of Thales. If you're watching this broadcast live, I'll put the link in the Zoom chat facility so that you can register for next month's Tech Talk. Or if you're watching the recording of this Tech Talk, you can go to aesin.org.uk and click on the events section to register for that. So, Q&A time. Ross, I'll start with the first question. As a component supplier, what would be the obligations of SOTIF?
So, SOTIF deals with the behavior of the vehicle at the highest level. Again, come back to that pathology, but then gets down to what's the components that might cause hazardous behavior if they've got insufficiency, and then get down to what are the triggering conditions. So if I was a component supplier of the perception components, I would be expecting to get a barrage of questions from the OEM to say, how does your system deal with this particular condition, be it rain, fog, snow? Have you done some testing of it? What happens to the performance of say, a sensor or a perception system under these conditions? So the component suppliers will be, a key part in being able to answer these questions.
Okay, thank you. One of the questions coming in on the Zoom chat, this is from Manoj. When would or should SOTIF analyses be conducted? Before, after, or parallel to functional safety analyses?
So, as I mentioned, SOTIF is complementary functional safety, and our finding is that there's particular aspects that are actually can be done in common. So it's definitely in parallel. The thing that we found we could share pretty much between the two analyses almost wholly is the 𝗧𝗲𝗯. So we were able to take the functional safety, hazard and risk analysis and reuse it in the SOTIF context. And certainly when we start to design the test and things, it was useful to understand the safety system and the measures that come out of the functional safety design to deal with malfunctions, to understand, well, what was their contribution in a SOTIF context. So yes, definitely it has to be done in parallel. And some of the testing then starts to become parallel as well. So a single test can answer a question for both SOTIF and the functional safety.
Okay, thanks for that question, Manoj. Mohammed asks, where are we? Criteria of applicability of SOTIF. Is it to be applied only on autonomous systems or stroke functions? If yes, should the SOTIF applicability be extended to interfacing systems stroke functions? That's from Mohammed.
SOTIF is generally around the perception elements of it. So generally the analysis is constrained mainly to those perception elements of the system. I think in terms of then doing some of the evaluation work and considering whether hazards occur, then you inevitably start getting out beyond the breadth of that and understanding more about interfacing system in terms of perhaps processing the actuation system, in terms of trying to assess, okay, given this failure to perception system, how likely is it to occur into hazard? So it tries to bound it there. I would say the functional safety analysis does tend to get further beyond, but so you can borrow to a certain extent from that.
Okay. All right. Thanks for that question, Mohammed. Michael has put quite a few esoteric terms in his question, so I'm going to have to try and read this with care. When quantifying the conditional probabilities on the basis of V&V test evidence, do you take a statistical approach? Bayesian maths, in essence, do you incorporate the fact that you'll always have uncertainties on those very conditional probabilities?
Yes, the conditional probabilities require a bit of careful thought because to try and to verify them, we've used figures from sort of standard methods used in the 𝗧𝗲𝗯 for coming up with some of these probabilities. But we've also tried to sometimes gather further information through testing. As you say, you've got to understand the mathematics of conditional probabilities to make sure you don't con yourself, for sure. So yeah, you've got to be mathematically correct. One of the things that we're finding is that you've got, and again, this is part of the field monitoring, you have to monitor these condition probabilities as well to make sure that the field experience recognize these. But yes, there will be a level of uncertainty in these calculations for sure. That's why perhaps you need to be conservative in your approach to them.
All right, thank you very much for that question, Michael. And maths wasn't my particular strong suit, so I have no clue what Bayesian maths is, but I'm intrigued to look that one up. I think that's pretty much all we've got time for. I'm afraid we're 6 minutes over schedule as it is, so apologies if you've had meetings to go to or anything like that. But we wanted to get some of well, all of the questions asked in. As I said, next month's AESIN Tech Talk takes place on Wednesday, the 16th of October. The presentation will be 𝗧𝗹𝗸 and the Economics of Hardware Cybersecurity, and that's with Peter Davies of Thales. If you'd like to register for that, the link to register is in the Zoom chat facility right now, as are details of the TechWorks Awards and Gala dinner. Thank you very much to Ross McMurran of 𝗧𝗹𝗸 joining us from Leicestershire today. We'll be back next month with another Tech Talk. In the meantime, thank you very much for joining us today.